Hello everyone, and thank you for taking the time to log into today's webinar. Today we will take a detailed look at STAT's BISEP isolation tool, which is the world's first true double block and bleed line stop, using unique patented technology to give 100% leak tight seal for your breaking of containment activities. This is a short list of the items we'll cover in today's webinar. Firstly, a company overview of STATs, followed by looking at the reasons why we break containment and what activities may require a temporary isolation. We will look at the definition of different isolation barriers and what measures should be taken to reduce the risk to as low as reasonably practicable, or a LARP, if the positive isolation barriers are not achievable. Following this, we will give a brief overview of traditional line stopping technologies, which I am sure many of you will be familiar with, including the technical, operational and safety challenges associated with these well-known methods. We will take a detailed look at STAT's BISEP isolation tools and how the unique features address all of the recognized issues and challenges with traditional line stopping to give operators the best isolation available on the market. We will also highlight how our BISEP tool is compatible with existing line stop tees and valves provided by other vendors and the commercial advantages that can give customers using their existing stocks while providing the safest barrier possible for their worksite. Then we will present a number of field deployment scenarios and how the BISEP has been used for customers on live projects, before finishing with a summary of the tool's extensive track record and global customer base. So to start, STATs are a global service provider to the oil and gas industry, with our company headquarters based in Kintore, just outside the city of Aberdeen in the UK. We employ over 250 people worldwide and have grown over our 22 years in industry to having 6 fully operational bases throughout the globe, supporting the key oil and gas producing regions. In addition, we have a project support office based in Perth, Australia, which we expect to expand through continued growth in this region. In summary, STATs are a global company with a proven track record in the ability to deliver and support services in all the major oil and gas regions for some of the world's biggest operators and EPC contractors. Now we will briefly outline some of the reasons why operators may need to break containment on pressurized systems, which can be for a number of different activities. One of the most common is for the repairing or replacement of valves. Other reasons can include creating tie-ins for new infrastructure, creating bypasses, installing new facilities, or replacing damaged pipeline sections in the case of corrosion or third-party interference as part of an EPRS system. All of these scenarios require temporary isolation barriers to create a safe working area where existing system valves are not suitable, or when it's not possible to fully flatten the pipeline pressure and remove its hazardous contents. This is where STAT's specialist isolation tooling can be used. We are all fully aware that depressurizing and purging the pipeline is the safest method of preparing a worksite for the breaking of containment. However, this is not always practical to do for many different reasons, such as time, the cost of venting pipeline contents, waste disposal and environmental impact, or potential issues like hydrate formation in gas pipelines. Therefore, in order to break containment, the highest level of isolation must be used in order to reduce the risk to a LARP. The best possible isolation is a positive or physical separation of the line by removal of a spool or installing a spade or blind. If this is unachievable, then the next best level of isolation is a proven double block and bleed barrier, which must be used. This is normally done by closing 2 valves, bleeding between them, and most critically proving each barrier to the full line pressure before it is relied upon. Due to problems with aging assets, passing valves, or the distances between 2 available system valves, it may not always be possible to create a double block barrier. A temporary isolation tool should then be considered, which gives the assurance of a fully proved double barrier at the full pipeline pressure, with a zero energy zone between 2 seals. This void or annulus space between both seals should be kept to an absolute minimum and monitored throughout the isolation period. This type of isolation ensures that no single barrier failure will cause a risk to the personnel or environment at the worksite, and that's what STAT's isolation tooling provides. So I know many of you are very familiar with traditional line stopping techniques, but it's beneficial to briefly review those and note some of the challenges associated with these setups. There are a number of different configurations, from a single line stop with a gas bag or a dual seal tool on a single plunging head to potentially 2 tandem line stops next to each other. All of these configurations require multiple hot taps to install the tool, along with creating bleeds or vents. Each tool of this type uses lip seals which do not guarantee a leak-tight barrier, hence the requirement for additional vent ports, and have limitations on pipeline pressures, including difficulty sealing in poor pipe conditions. The tools are also unable to facilitate reverse pressures for carrying out reinstatement tests, making it difficult for operators to verify the new pipe joints. The on-site challenges with requiring multiple hot taps include increased lifting and rigging or hot work activities, along with extended durations before plugging can begin at the site. Traditional line stops use multiple sealing elements for the same diameter of pipe due to requiring an interference fit to seal. This can increase the risk of operator error if the wrong seal is selected for the pipe schedule being worked on. These seals can also be easily damaged when coming into contact with cuttings left in the line from the hot tapping operations. Industry has been driven to accept that line stopping involves the management of a leak rate across a single or double seal. This isn't best practice and certainly isn't reducing the risk to a LARP when other solutions are available to address these problems. STAT's BISEP isolation tool, which uses dual hydraulically activated seals and no single mode of failure, addresses all these issues to provide an isolation which can be relied upon for the breaking of containment. The STAT's BISEP, as I've mentioned previously, is the world's first true double block and bleed pipeline isolation tool. The BISEP was created in response to a demand from our industry to provide a better method of line stopping and has been used extensively since its first project in 2006. Our tool has gained DNV GL and IMCA D044 approval, having underwent an extensive testing and validation program for topside, onshore and subsea use. The tool consists of dual hydraulically activated seals, which are each tested independently to the full line pressure, giving a 100% leak-tight seal. This is the definition of a safe isolation, with the risk being reduced to a LARP. The zero energy zone in the annulus void between both seals is continually monitored throughout the entire scope, and the BISEP is hydraulically manipulated through a single hot tap fitting, meaning it can be used in any orientation, either vertically, horizontally or angled, without the risk of becoming stuck on deployment or recovery. By only using one fitting, the length of the pipe required for installation is also much shorter, meaning the tool can fit in tighter space envelopes. Before being set inside the pipe, the seals are retracted to be smaller than the bore, meaning they are not at risk of becoming damaged while being deployed into the pipe, and as you can see from the image, the sealing head is deployed towards the pressure source, which is different from traditional line stops. This gives the advantage that meaning that the BISEP launcher and valve assembly is not pressurized during breaking of containment, and allows the venting and purging of the isolated section to be carried out behind the tool, without the need for any additional hot taps. Also, the seals used are bidirectional, and the sealing head can accommodate reverse pressures to fully test the new pipe joints without disturbing the isolation barrier or impacting the work site. Once the tool has been hydraulically deployed and set, the isolated section is vented and purged, which can be done from the BISEP launcher can. This then creates a full differential pressure acting across the tool. The annulus between the seals is vented to ambient, or in the case of low pressure isolations, this can be pressurized to create a positive pressure and prevent any content migration. Both seals are tested individually to the full line pressure in the correct direction and held for a period of time, which varies depending on the scope duration, but is typically 2 to 4 hours before a certificate of isolation is issued and site works can begin. This short animation shows how the BISEP is deployed, set using hydraulics which are provided from an external console, and then tested before venting and purging the line. The BISEP is deployed towards the pressure source, and the internal hydraulic piston compresses to expand the seals radially to the inside of the pipe diameter. This scope you're seeing is a live project which was carried out using dual 30-inch BISEP tools on a liquid CO2 line at class 900 pressures. This was a world's first for the use of line stop tools in this type of pipeline service, and it highlights the ability of the tool to provide 100% leak-tight seal in challenging mediums. When both BISEPs are deployed, the seals are tested to the full pipeline pressure by venting the pressure behind the tool, monitoring for a pressure drop in the annulus, venting that down, and then monitoring for a pressure buildup. This proves both the secondary and primary seal to the full pipeline pressure. At this point, the contents behind the BISEP can be vented and purged. Once the line contents behind the isolated section are removed and production is continuing through the additional bypass tees, which you can see, the isolated section can be cut out. In this case, this was to install pigging facilities. The new section can be tied in, as shown in the animation. Welding can take place safely behind the tool without the need for any gas bags. Beside a 100% leak-tight monitored seal. At this point, pressure can be introduced through the launcher cans to fully pressurize and test the new joints, all the while the isolations remain undisturbed. On completion of a successful test, both isolations can be hydraulically unset and the BISEP tool heads retracted before finishing the scope with leaving completion plugs into the split tees. I mentioned before that the tool is hydraulically set, and once the line is vented, has a differential pressure acting across the sealing head. This creates what we refer to as self-energization, and means that even in the incredibly unlikely event of a failure of the hydraulic system, that the isolation and worksite will not be compromised. This dual redundancy gives operators the assurance that they are using the highest level of isolation barrier available, where the risk to the worksite is minimized and personnel are working behind a safe barrier at all times. The BISEP tool is qualified and available in a wide range of pipeline sizes from 3-inch to 54-inch and is fully NACE MR0175 and ISO 1516 compliant. Our tooling is available for pressures up to class 900 in either liquid or gas service and within temperature ranges between -20 to +100 as standard. However, applications outside these ranges can be addressed on a case-by-case basis. We have also used this BISEP isolation in steam lines previously, another case of showing where the tool can be used in challenging environments. I referred previously to the self-energization feature using differential pressure to give it dual redundancy and activation. The amount of line pressure required for this to happen varies depending on the size of the BISEP. However, generally this is between 4 and 10 bar. Another key difference between the BISEP and traditional line stop technologies is that the higher the line pressure, the better for the tool, meaning operators are not forced to reduce pipeline pressures to install the isolation. So until now, we have detailed the BISEP in its standard configuration, which stops pipeline flow and ultimately production unless a bypass is put in place, which requires the use of additional pipeline fittings as shown in the slide image. There are occasions where the continuing of flow and production is essential, and stats are able to assist with this while still being able to provide the same dual redundancy double block and bleed barrier given in the standard configuration while removing from the need for any additional fittings. Introducing the Stats Dual Set BISEP. This configuration uses the same isolation technology and principles, however, as the tool is deployed in the opposite direction, allows for production bypass to be routed through the launcher can, therefore eliminating the need for any additional fittings. The advantages of this configuration, which not only reduces the fitting quantities, includes the use of less equipment, reduced lifting operations and excavation, reduced line space requirements, and a reduction in the time to install the tools as a result of less hot work, while still providing a full double block and bleed barrier. The reason this BISEP configuration was developed was primarily to address the market demand for a more cost-effective double block and bleed isolation where production bypass is needed. All other isolation features of the tool remain the same, with a fully monitored isolation being provided throughout the scope. This configuration is suitable for a wide range of pipeline repair applications, including EPRS, both topside and subsea. The dual set BISEP is field proven and has a track record on live applications for a wide range of clients internationally. The dual set BISEP is available in the same size ranges as the regular tool and complies with the same codes and standards. The only notable technical difference is the pressure range is limited between ambient and 82 bar for this configuration. Stats are aware that many pipeline operators across the world hold stocks of hot tap tees, valves and completion plugs from other line stop providers. We understand that this can make some operators hesitant to consider other options. During the design of the BISEP tool, a key requirement was for the Stats equipment to be fully cross-compatible, allowing it to be used with any operator's existing stock, as the image on screen shows. This design feature gives operators a number of significant technical and commercial advantages, such as being able to use their existing stock of tees, reducing project costs, while still providing a fully proven double block and bleed isolation to significantly improve worksite safety at the point of breaking and containment. Stats have carried out numerous live projects using tees sourced from other line stop providers, proving this point and the advantages seen by the end client. Now I'd like to show a sample of case studies where the BISEP tools have been used to provide critical isolations in different repair scenarios. The first is a dual standard BISEP deployment with a 30-inch bypass in the Middle East for a large gas operator. The client is requiring temporary isolations for tying in new pipelines while maintaining production. The two stats biceps were in place for a 7-month period while providing continuous 100% leak-tight isolations. The level of isolation given by the bicep is so secure that the client on-site contractors were able to weld in the new pipeline sections within 1.5 meters of the bicep tools without the need for any gas bags, which are commonly required for traditional line stop tools. After the new sections were tied in, a reinstatement pressure test was carried out between the two biceps, proving the joints before the isolations were unset and recovered. Another example of how the bicep has been deployed is this 4-inch isolation project, which was used to maintain flow using the dual bicep with integrated bypass while modifying the pipeline around a water crossing. The scope involved installing 2 dual set biceps on either side of the water crossing to maintain a bypass and not interrupt flow. Once the isolation certificates were issued and all 4 barriers were being monitored, work could begin to reroute the line and tie in the new section. The newly installed section could be fully tested against the bicep tools before the isolations were removed and completion plugs were installed. The dual set bicep has also been used in larger diameter scopes, such as this 20-inch project in North America, where, as you can see from the images, the level of excavation to install the tools is greatly reduced while production remains uninterrupted. This increases worksite safety and means much less time to install the tool on the line within a much restricted space. So in summary, the bicep offers many significant advantages over traditional line stop methods in terms of safety, time and costs by giving full double block and bleed isolations using fewer fittings and being able to ensure no loss of flow or production. To finish, I would like to leave you with this short overview of the bicep track record and a sample of our client list. Thank you very much for taking the time to listen to today's webinar.